Hello students, this is Miss Michael from Parkview High School, and this was a brief video going over enzymes and how they become denatured and reading a graph. Okay, so we spoke, or I reviewed this last video. We went over an example of heating proteins and how it changes the shape of the active site on an enzyme. Again, an enzyme is a protein that is going to speed up chemical reactions, and it's going to help either break down a substrate, which would be this little piece here, or it's going to change the substrate into something totally different. When it's exposed to temperature or a different pH, what happens to this active site is it becomes completely different. It changes the shape of the active site, and the enzyme becomes denatured. Therefore, it's either not going to work at all or it doesn't work as well. Here is another picture of what happens with the active site. You can see that this one is an enzyme and a substrate that are going to fit perfectly, and that chemical reaction is going to happen quicker. It's going to be more of a successful chemical reaction. Number 2 here depicts a slightly changed active site, which means this enzyme has become denatured. And again, 2 factors that affect the protein of the enzyme being able to speed up the chemical reaction. It's going to be pH and temperature. So as pH and temperature change, it changes the active site on the enzyme. Now we're going to look at this graph here. This graph is representing temperature in degrees Celsius, and then here is representing the enzyme activity. Okay, so right here we see the enzyme activity being the highest, and it's the highest at about 37.5 degrees Celsius. So the scenario states there's a certain temperature at which enzymes catalytic activity is at its greatest. That means it's going to be its most effective. Okay, if something is a catalyst, it's going to be something that helps to speed up a reaction. So we call it an enzyme's catalytic activity. This is the optimal temperature. Optimal just means best. This is the best temperature. This optimal temperature is usually around human body temperature of 37.5 degrees Celsius. Now that's Celsius, not Fahrenheit. Normally we measure in Fahrenheit when we're looking for fever, but 37.5 degrees Celsius is the ideal optimal temperature for enzymes to work the best in the human body. Okay, so the question states, what happens to enzymes at 40 degrees Celsius? Well, 37.5, it's at its best. Okay, what happens to the enzyme activity? It begins to drop, it begins to decrease. Okay, so it's decreasing because something is happening to the active site. That active site is beginning to change shape. Okay, now this diagram represents probably what's happening at 45 degrees. That active site is completely been changed, and that substrate is not going to fit. So again, what is happening to the active site of the enzyme once it passes its best temperature, its optimal temperature? It's going to start to become misshaped, and it's going to become denatured. Okay, and at 50 degrees Celsius, it's become completely denatured, and that's a problem. All right, so 37.5 degrees Celsius, your enzyme and the active site on the enzyme looks like this, and it's going to fit perfectly with the substrates. Okay, so diagram A represents this 37.5 degrees Celsius. Diagram B represents the 45 degrees Celsius, where it's almost just completely denatured, and it's not going to work. All right, another scenario we have is pH. We have certain pH levels in our body that are going to be the best. And mostly in the blood and the saliva have a pH of about 7. That's pretty neutral. Okay, we have other areas of our body like our stomachs that are very acidic. because they have to be. We have to digest food. But for enzymes that are in our other places in our body, like our blood or saliva, the best pH is going to be around 7.2. Okay, if we look at this graph, we can see enzyme activity is at its best right here at that neutral pH. So it states, for most enzymes to operate in the body, the optimal or best temperature is 37 degrees Celsius or 98 degrees Fahrenheit. Most of the human enzymes have a maximum activity at a pH around 7.2. So pH is very important in homeostasis, very important in how this enzyme is going to work. So most body fluids are around 7. And then here it mentions pepsin. Pepsin is in your stomach. It's one of those. It's in a couple places in your body, but there are a couple. Like I said, there are a couple of different areas in your body that you don't have that pH level. So again, what happens to the enzyme at a pH of 8? We're right here at about 7.2. Like they said, enzyme activity starts to go down. Okay, it starts to go down. So what's happening to the active site at a pH of 8? It's the active site, again, it's going to change shape. Now, it may not look like this just yet, but the activity of the enzyme, the effectiveness of the enzyme, it's going down. It's changing the shape of this active site. So here it asks you which diagram would illustrate the enzyme and substrate at the pH of 7.2. It's going to be diagram A because it's perfect. It's going to have the enzyme and the substrate perfectly fit into a nice little puzzle piece of an active site. At the pH of 11, the enzyme really appears it's not really going to work at all. It's not compatible. So diagram B represents the pH of 11, and you can see right here that active site has changed shape. It has become denatured. Okay.